All right, starting number 1, we have to solve for r. So first thing I'm going to do here is distribute. All right, on both sides, so I have 14 minus 2 plus, be careful with that, 10r is equal to 12 plus 4r plus 6r. All right, I wrote 4, supposed to write r. Okay. R. All right, now I need to combine like terms on each side of the equation. So I have 14 minus 2, that's 12, plus 10r equals, on the right side of the equation, I have 10r and 4r and 6r is 10r. All right, and now I'm going to move this over. So I have 10r is equal to, that cancels out, 10r. Okay, well at this point you don't need to do anything else. You have an equality, that's true. I could just as well do this. R equals R, okay. Well, that's true. So that means there are infinitely many solutions. All right, it doesn't matter what number you plug into this equation, it's going to work. Next. All right, here we have an absolute value. Okay, here's a little side note. If you have absolute value of x is equal to 5, well, what's x equal to? It's equal to 5. It's also equal to negative 5. So keeping this idea in mind, we're going to apply the same approach to solving for z in this case. 3z minus 12 is equal to 6, positive 6, and 3z minus 12 is equal to negative 6. Here I add 12. 3z is equal to 18. Divide by 3. And z is equal to 6. For the next one, I have 3z is equal to 6. Divide by 3. And z is equal to 2. Those are your two answers. All right, for the next problem, I simply have to isolate x. So I subtract 28. I get negative 4x is less than or equal to 2. I divide by negative 4. Now be very careful when you divide by negative, you have to flip the inequality sign. So I end up with negative, and 2 over 4 simplifies to 1/2. Make sure you don't write 2. Be very careful with that. Compute the slope of the line containing the given points. All right, slope formula is y1 minus y2 over x1 minus x2. x1, y1, x2, y2. All right, so I have m is equal to y1, which is negative 6, minus y2, which is negative 8, over x sub 1, which is negative 2, minus x2, which is 8. So I get negative 6 plus 8 over negative 10. So I have negative, not negative, I have 2 over negative 10. And that simplifies to negative 1/5. Not 5, negative 1/5. All right, that's your slope. Graph the equation. All right, in order to graph, we have to convert it into slope-intercept form. So the first thing I'll do is subtract 2x. And those are unlike terms. So I write negative 2x plus 21. Maintain that y equals mx plus b structure. Divide by 7. I divide 7 into both parts, so I get y is equal to negative 2 over 7, x plus 3. All right, so I start off at 3. All right, and then I have negative 2 over 7, so I go down 2 and I go right 7. Then I go up 2 and I go back 7. All right. Done. Write the equation of the line that passes through the given points. Okay, so first thing I need to do is figure out the slope using these 2 points. All right, and then I got to set up my equation, y equals mx plus b. Let's first figure out m. This is x1, y1, x2, y2. Plugging in my values, I get y1, which is 7, minus y2, which is negative 9, over x1, which is negative 1, minus x2, which is 3. So I have 7 plus 9 over negative 4. I have 16 over negative 4, which is negative 4. All right, so m is negative 4. I'm going to plug that into my equation. So I get y is equal to negative 4x plus b. Now the next step is very easy. You choose which point you want to work with. All right, the x and y values. I'll choose the first point. So I'm going to plug in the y value, and I'll plug in the x value. And I get 4 plus b, subtract 4, and b is equal to 3. Take this, plug it in, and I have the equation of my line. Done. All right, solve the system of equations by substitution. Okay, this is easy. X is already isolated, so I simply plug this in for x right here. So I have 2y minus 10 times 2y plus 18 equals 0. So I distribute, and I get 2y minus 20y minus 180 equals 0. So I get negative 18y minus 180 is equal to 0. I add 180, and I get negative 18y is equal to 180. Divide by negative 18, and I get y is equal to negative 10. But I'm not done. Okay, you still have another variable to solve for. So not done yet. I have to plug it in. So I get x is equal to 2 times negative 10 plus 18. So I get negative 20 plus 18. So I get x is equal to negative 2. All right, now I get a point as my solution. X comes first, y comes second. Done. All right, consider the function g of x is equal to x squared minus 4x plus 8. What is g of 5? All right, g of 5 means I'm taking the x value and I'm replacing it with what? 5. So I plug in 5 for x here. So g of 5 is equal to 5 squared minus 4 times 5 plus 8. So I get 25 minus 20 plus 8. All right, and I get 5 plus 8, which is 13. That's my answer. All right, determine f of 2, f of 3, and f of 4 for the function below. F of 2. All right, how does this work? Well, there's restrictions based on the expression. Now, for this expression, only x values that are less than or equal to 3 work. For this expression, only values that are greater than 3 work. So here I'm working with 2. Which expression will I work with? Well, 2 is less than or equal to 3. So I'm going to use the first expression. 2 times 2 minus 1. So 4 minus 1, which is equal to 3. So f of 2 is equal to 3. And then f of 3 is equal to, let's see, 3 is less than or equal to 3. So I'm going to use the first expression once again. 2 times 3 minus 1. That's 6 minus 1, which is 5. So f of 3 is 5. And for the last one, f of 4 is equal to, well, 4 is greater than 3. So I'm going to use the second expression. 3 times 4 minus 4. That's equal to 12 minus 4, which is equal to 8. So I get f of 4 is equal to 8. Done. It's as simple as that. All right, simplify each expression. Okay, there's a lot going on here. I'm going to work with the numbers first. Negative 2 times 4 times negative 8. So negative 2 times 4 is negative 8. Negative 8 times negative 8 is 64. All right, here I have k to the first power. I have k to the third. Then I have k to the second. If I multiply all these, I get 1 plus 3, which is 4, plus 2, which is 6. So I have k to the sixth. Now for the m's, I have m to the third. 0 m's here, and I got m to the first. So I multiply these, and I get m to the fourth. So that's my final answer. Simple as that. Simplify each expression. Okay, here I have -2. This is to the first power. Okay. And I could take this whole thing if I want. I'm going to keep that negative on the outside there. All right, got this whole thing here. -2 to the first power, and I got d to the third. So I just multiply the exponents by that 5. So I have -2 to the 5th power then, and then I have d to the 15th power. And what's -2 to the 5th power? We just got to work out -2 times -2 times -2 times -2 times -2. That's 4. That's -8. That's 16. And that's -32. So I have -32 d to the 15th power. Done. Solve each equation for the given variable. All right, here you have to strategize a little bit. Here I have an 8 to the x. Here I have a 16 to the 4x minus 1. All right, I could set these equal only when the bases are the same. All right, so this is a little challenging in the beginning, but once you get the hang of it, it's really easy to do. So how do I rewrite 8 as a power? I'm going to rewrite it as 2 to the 3rd power. All right, how do I rewrite 16 as a power? I'm going to use the same base. I'm going to write it as 2 to the 4th power. You could write it as 4 to the 2nd, but then you wouldn't have the same base. You want to have the same base. All right, so then I have 4x minus 1. All right, so now I multiply these. I have 2 to the 3x power is equal to 2 to the 16x minus 4 power. Okay, and now I have the same base, so I set the exponents equal to each other. 3x is equal to 16x minus 4. I subtract 16x, and I get -13x is equal to -4. Oops. Let me clean that up a little bit. And 4, and I divide by -13, and I get x is equal to 4 over 13. Done. Okay, here we're going to find the difference. All right, this is the part where you need to be really careful. I'm just going to clean that up here. All right, I have to distribute this negative, and if you don't do that, that throws everything off. So be really careful with that. The first part you don't have to do anything with. In the second part, I get plus 17 minus 11x plus 19x squared minus 12x cubed. Okay, now we need to add like terms. So let's see. Start off with the highest exponent. -19x cubed minus 12x cubed is -31x cubed. Then I have 10x squared plus 19x squared is 29x squared. Then I have 11x minus 11x. These cancel out. Then I have -29 plus 17, which is -12. And that's it. That's all you have to do. Done. Find the product. Here we're just multiplying. So I get positive 14, and it's going to be y to the 3rd. Then I have -7, y times y is y squared. Then I have -7 times 10 is -70, and y. Done. For the next one, you have to distribute a bit. It's like a bigger version of FOIL. So multiply here and multiply that way. So I have w cubed. Then I have -2w squared. Then I have -7w. Then I have plus 5w squared minus 10w minus 35. Then you add like terms, so nothing to do with the w cubed. -2w squared plus 5w squared, which is plus 3w squared, minus 17w minus 35. Done. All right, so I have 9h minus 5 squared. I'm going to expand this to this. Make sure you don't make this classic mistake. A lot of students, they do this. They write this as their answer. All right, and that does not work. All right, you cannot distribute the 2 to the exponents when there's an addition or subtraction in between. All right, now I'm going to have to FOIL here, and watch how my answer differs from if you had done this. So I have 81h squared minus 45h minus 45h plus 25. So I end up with 81h squared minus 90h plus 25. Done. All right, for the next one, simply FOIL, and you get 36c squared plus 30c minus 30c minus 25. Those cancel. Left with 36c squared minus 25. Done. All right, factor each polynomial. All right, so here we have to look at what's the biggest number that divides evenly into 12 and 21. That would be 3. Now we look at the variables. I have 3 k's here. I have 5 k's here. If I have to pull out an equal amount of k's from each term, how many can I pull out? 3. So now what's left over? 3k cubed times what is 12k cubed? That would be 4. 3k cubed times what gives me 21k to the 5th? That's 7k squared. That's all there is to it. We're done. All right, now I'm looking at a quadratic expression that I have to factor. Since the a value is 1, I use the big X method. I need to find 2 numbers that add up to negative 14 and multiply to give me 49. Those 2 numbers would be negative 7 and negative 7. So I simply factor it into 2 binomials. My variable is p. My numbers are negative 7 and negative 7. You know if you did it right simply by foiling, and it should take you back to what you started with. That's the beauty of the factoring problems. You typically can tell if you did the problem right or not. All right, factor each polynomial. We're factoring, so we want to look at these expressions and try to see what type of factoring situation we're dealing with. So here I have 25. I could rewrite that as 5 squared. Then I have p squared minus 9 squared. And I can rewrite that as 5p, the whole quantity, squared minus 9 squared. This is a difference of squares. So being familiar with the difference of squares, you know that factors into 2 binomials. The first part is 5p for each. The second part for each is 9. All right, and then one value is plus, and the other value is minus. All right, that's all there is to it. Solve each equation for the given variable. Okay, now they already have this in factored form for us, so they made our life easy. All right, just set each factor equal to 0. All right, so here I subtract 2. 3b is equal to negative 2. I divide by 3, and b is equal to negative 2/3. All right, then I have the next equation. 3b is equal to negative 1, divide by 3, b is equal to negative 1/3. And that's all there is to it. Done. Solve each equation for the given variable. Okay, here we're dealing with a quadratic equation. We have to factor this. A is equal to 1, so I just use the big X method. You need to find 2 numbers that add up to negative 3 and multiply to give me negative 10. That's going to be 2 and negative 5. So I factor this into m plus 2 times m minus 5. And now I simply set each factor equal to 0 to solve for m. Subtract 2. So m is equal to negative 2. Here I add 5. So m is equal to 5. And that's all there is to it. All right, determine the vertex of each quadratic equation. All right, a little reminder here. The vertex. the x value for the vertex is what? It's whatever the axis of symmetry is. The axis of symmetry is negative b over 2a. All right, so to find my vertex, I have to first identify my a, my b, and my c. So let's get my x value for the vertex. It's negative b. b is 12 over 2 times a is 1. So I have negative 12 over 2, which is negative 6. So x equals negative 6. So that's the first part for my vertex. Now how do I figure out the y value? We simply plug it in. F of x is the same thing as y. So y is equal to 3 times negative 6 squared plus 12 times negative 6 plus 7. So I get 3 times 36 plus, or I should say, minus 72 here, plus 7. So I get 72 minus 72 plus 7. Cancels out, I get 7. All right, so that's my y value. Done. All right, find the x-intercepts of each parabola. All right, to find the x-intercepts, you set what? Y equal to 0. All right, and do the same thing that I did before. I'm going to use the big X method. I need to find two numbers that add up to 1 and multiply to give me negative 20. Those two numbers are negative 4 and 5. So I have 0 is equal to x minus 4 times x plus 5. So I have x minus 4 is equal to 0, and x plus 5 is equal to 0. So I add 4, x is equal to 4, subtract 5, x is equal to negative 5. Done. That's all there is to it. Classify each equation as linear, quadratic, cubic, or exponential. All right, linear is this. Okay, that's linear. Quadratic is this. Does that look like what we have? Yes. Okay, but let's go over the others as well. Cubic would look like this. All right, it just means the degree is a 3. And then you have exponential, which is something like this, meaning that your variable is in that exponent position. All right, so what do we have for number 49? We have a quadratic. All right, and when we graph a quadratic, what do we get? We get a U-shaped graph known as a parabola. All right, if you have any questions, if you need any clarification, please make sure to ask.